Ion traps. An ion trap is a combination of electric or magnetic fields used to capture charged particles in vacuum. A single trapped particle floating forever at rest in free space would be ideal object for precision measurements. Apart from measurements and research, trapped particles can also be used as bits of a computer. The state of the bit is defined by the position of the trapped particle, which can be controlled by electric fields or even lasers. We'll be talking about two types of ion traps. Firstly, Paul traps. A Paul trap is a type of a quadruple ion trap that uses static DC current and radio frequency oscillating electric fields to trap ions. Paul traps are commonly used as a component of a mass spectrometer. The trap consists of two metal electrodes which are in hyperbolic shape with their foci facing each other and a hyperbolic ring electrode halfway between the other two electrodes. Ions are trapped in the space between these three electrodes by oscillating and static electric fields. Here is a video of a linear quadruple ion trap. Firstly, the charged particles are attracted inside, and then as we can see, they get trapped inside the linear region.
A panning trap stores charged particles using a strong homogeneous axial magnetic field to confine particles radially and a quadruple electric field to confine the particles axially. Setup used for panning trap is different for negative and positive charged particles, whereas in Paul trap it doesn't depend on the polarity of the charged particles. Panning traps can be used for precise magnetic measurements in spectroscopy. Panning traps are well suited for measurements of the properties of ions and stable charged subatomic particles. Panning traps can be used in quantum computation and quantum information processing and are used at CERN to store antimatter. Panning traps forms the basic of Fourier transform ion cyclotron resonance mass spectroscopy for determining the mass to charge ratios of ions. We have a video showing how a Paul trap is made simply using spoons and a metallic ring. Here the voltage applied is 3000 volts, and when we can see the trapped charged particle in the ring using a laser light.